Hello and welcome to Mr. Jackson's class. Today in Chemistry B we're going to talk about percent composition. We've been dealing with the mole idea and the mole conversions, but what we want to show you is what we can do sometimes with similar ideas. But today we're going to talk about percent composition. It's determining how much an element contributes to the overall weight of the compound. So if it gives the material, gives percentage by weight, the contribution of each element to the overall weight of the material. Okay, so what does that mean? What that means is whenever you have a formula, let's just say we have, calcium hydroxide. Okay, there is a certain amount of weight that calcium puts into the formula, and there's a certain amount of weight the oxygen puts in, and a certain amount of weight the hydrogen puts in. Each element contributes to the overall weight. So we want to figure out what's that percentage of each one. So let's go through the steps. It's actually pretty easy to do. It's based on a lot of steps that we're already doing in class. So let's look at it. Okay, here are the rules for doing percent composition. Okay, the first thing you do is you count the atoms in the formula. Okay, so like right here we would have 1 calcium, 2 oxygens, and 2 hydrogens. Okay, then what you want to do is you want to find the element's weight and the total formula weight of the compound. So what you'd want to do is multiply each one by how much they weigh, and then you would go on from there. Okay, and so this one, of course, would be 1.0. This one weighs 16 because each element has a lot of different weight. They have more electrons, protons, and neutrons, so no single element has the same weight as another element. And calcium, if I look it up, it is 40.1. Okay? And so then what you do is after you find the total overall weight, which you have to multiply everything down through, so 40.1, 2 times 16 is 32, and 2 times 1 is 2. Add them all up, you get your weight, you get 0.1, and then you get 4, and then you get 74. So 74.1 is the total weight. 40 is the calcium's contribution, 32 is the oxygen's contribution, and 2 is the hydrogen contribution. Okay? Then what you do is, since it's called percent composition, you multiply, you take these numbers here and you divide them, okay, by the overall formula weight. So for calcium, we take the 40.1 and you divide it by the 74.1. And then for oxygen, you take the 32 and you divide it by the 74.1. And then you take the hydrogen, which is 2, and you divide it by the 74.1. And what you come up with is decimal numbers. And you want to keep at least 3 decimal numbers. So if I did my math here, clear this off, we get 40.1 divided by 74.1. And we get 40.1 divided by 74.1. There we go, much better. We want to carry at least 3 decimal places, so 0.541. And then we take 32 divided by 74.1, and you want to hit 0.431, but the 8 is going to push up this 1, so 0.432. And then we have 2 divided by 74.1, and we get 0.0269. This 9 here rounds, okay, we only have 3 is it, so 0.26, but this 9 pushes up, so 0.27. So 0.027, 3 places, okay? So now we've done that. We've divided each element's weight by the overall weight. There it is, okay? Now the last step for this is really simple. We multiply all of these decimal numbers by 100 to turn them into a percent. So I jumped ahead of myself there for a second. So all it really does is it moves a decimal 2 places to the right. And so this one becomes 54.1%. This one over here, this next one, becomes 43.2%. This one becomes 2.7%. And when you're done adding it up, you should add up to 100%. If you don't, you got to be careful. You might get 99.9, that would be okay, because maybe you didn't round correctly on the decimal point. But if you're not near 100%, then you have a number wrong in here. So that's a quick, easy thing to check. So what am I saying? Calcium hydroxide, if you would actually put some of that on a scale, the reason why the scale goes up is 54% is due to the weight of the calcium atoms. 43% is due to the weight of the oxygen atoms. And 2.7% is due to the hydrogen atoms in that formula. Okay? So it's pretty simple to do. Okay? And so let's do one more example. Let's do it with water. Okay? So let's say we have water. Okay? And first step is to count all the atoms in the formula. So we have 2 hydrogens and we have 1 oxygen. We then find the element's weight and then the total formula. So we find the element's weight. Hydrogen's weight is 1. Oxygen weight is 16, which comes from our periodic table. Then we add them up and we get 18. So these, for the whole formula, water's formula weighs 18. Now what we do is we divide each of these element weights by the total. Okay? So we're going to take and go and divide 2 by 18 and 16 by 18. We get 0.111 and 0.889, which was 88888, but we had to round it off, and so the 8 brings that up to a 9. Then our last step is to basically multiply by 100, and so we did that. We'd multiply this by 100 and get 11.1%, and then for oxygen we get 88.8%. And I had, I guess, an 8 there. I don't know why, but I'm not worried about that. We'll scratch that out. Okay, and so what that adds up is to 100%. And so if you drink a glass of water, this is what it's telling me. It's telling me that as you drink the water, the weight that you added to your body from that water, 11% was due to the hydrogen atoms, and 88.9% was due to the oxygen atoms you took into your body. Okay? And that's percent by mass. Really simple, very straightforward, and easy to do. Okay? Well, thank you for joining me here in chemistry class, and you have a great day.